Okay, sixth grade, our objective today is to start reviewing for the 4-5 to 4-7 test, warm up first, and then last night's homework. So starting with number 1, Sean, can you tell us what the number is in standard form? Warm up. Good job. Briar, number 2. Good job. Annalise, number 3. Good job. Charles, number 4. Good job. Number 5, Justin. Nope. Careful. That's why I put this one up here. You guys don't like problems like number 5 for some reason. Alyssa? Good. 1 over m to the 4th. I noticed, now Justin, not you, but a lot of people yesterday, and when I checked page 59 last week, a lot of you guys were leaving m to the 4th on top. Remember, 6 minus 10 is -4, so then you need to move it to the bottom of the fraction, which means there's a 1 on top. Emma H? Okay, questions on 5? Emma M? Go ahead. Yep, that's a great strategy. Yeah. Emma H, number 6. Good. How'd you know that? Good. If the whole thing is raised to 0, the answer is 1. So that's a nice question for you, right? Nice and easy. Okay, Alyssa, number 7. Good. X to the 8th over y to the 2nd. Okay, number 8, Adam. Good job. Okay, number 9. Zach, did you get to number 9? What'd you get? Close. One little thing that needs to be corrected. Mary? Good. -2 squared, x squared. Now, here's why I put this problem up here. If there's a negative inside parentheses, I would leave that negative inside parentheses because that's telling you the negative goes with the 2. You're distributing that 2 to each term. -2 squared, x squared. Adam? Okay, why do you not have to move this? Why does this stay where it is, Briar? Yeah, the exponent's not negative. It's the coefficient that's negative. Does that make sense, Adam? So keep that where it is. Don't move it. Also, leave it like this because the answer is going to say keep it in exponential form. And I would like you guys to keep the parentheses here so you know that that negative stays inside parentheses. Annalise? Okay, did you hear what I just said? I want you to keep the parentheses there because that tells you that the negative goes with the number. I wouldn't mark it wrong. I might take off half a point. You got to keep those parentheses there so that the calculator and you know that the order of operations tells you that negative goes inside. Now, if I gave you a problem like this, why is this different than this? These two problems are very different. Justin, why are they different? Yeah. So this would be -2 squared x squared. If you simplify this one, it will be -4x squared. If you simplify this one, it will be +4x squared. This one says leave the negative outside, square it first, then put the negative in front. So these are very different problems. Be very careful. Adam? No. Do exponents, get rid of the parentheses first. Remember, get rid of those parentheses first, and you do that by distributing the exponent. So if that negative's in front, basically just leave it there. Don't do anything with it. Annalise? Remember I told you when you came over to see me, I told you not to distribute it? But you can't simplify 1 any further. Okay, but if you distribute 0 to everything, all of these are going to have 0 exponents. So all of those are going to be 1, even if you do it that way. Do you know what I mean? Okay, so if you want to do the extra work, you can, but you don't need to. Because if the whole thing is to the 0 power, that means every single term in here is going to have a 0 power, 0 exponent. Okay? Anyone else? Give me a thumbs up, thumbs middle, thumbs down on the warm-up. Just curious. Donatus. That's more of an Algebra 2 thing. The pre-algebra explanation, I know you guys always ask me, pre-algebra explanation is there's one way to write something to the 0 power, and that's no ways. So that's, for pre-algebra, that's as best as I can explain it for you. You will even do a little bit of this in geometry with the whole proof of it. For now, you guys don't know enough for me to really get into much detail about that. It's a very good question, though. You can ask Anna. She should be able to help you with that. Emma? Right. Yeah. That's the pre-algebra explanation of it. Sean? Correct. Yeah. I agree. Some things in math are kind of weird, but just is the way it is. Okay, let's go over homework, and then I would do a little more practice with scientific notation before we start our review today. Okay, number 1. Wait till you guys get there. Practice 4.7. All right, Briar, number 1. Good, 1.25 times 10 to the third. Justin, number 2. Good, 2.05 times 10 to the fifth. Matt, number 3. Good job. Number 4, Donatus. Okay, good. Alyssa, number 5. Good job. Number 6, Emma H. Good job. Number 7, Charles. Good. Mary, number 8. Wait, 72 what? Okay, that works. Number 9, Adam. Good. Number 10, Emma M. Nope. Unless I wrote it wrong. Do you guys have anything different? Zach? Yeah, 120,000. You just forgot a 0 there, which definitely makes a big difference. Adam, Briar, number 11. Just tell me the zeros. What's wrong? You don't have it done? Okay, give me number 12 then. You need to write the answer on the worksheet, okay? All right, do you have all these done? Okay, tell me 13. Okay, should be less than. Be careful on that. Okay, Sean, let's go back to 11. Good. Annalise, number 12. Good. 13 should be less than. 14 should be greater than. 15 should be greater than. 16 is less than. Anyone get 17? This was a trick question because I'm going to do these today. Matt? No. Are you on 17? Okay. Justin? Close? Really close, Alyssa? Awesome. 17, do not ask me a question about yet. We're going to do those in class. So if you didn't get 17 right, just put the right answer. We're going to come back to it. I didn't do those with you guys yet. I just wanted to see if you could get them. To get it, I should say. All right, questions on anything besides 17, because we're going to do that today. Matt. 15 you got equals to. Okay, I'm not quite sure how, because for 15, 6.9 times 10 to the negative third is 0.0069, which is not equal to 0.0068. You know what I mean? That's okay. That's all right. That happens. Annalise? It was like a puzzle, and I'm going to show you the little formula to solve that today. But it was like a tricky puzzle, I agree. Adam? Okay, I'm going to explain that, so just hold your thoughts on that. Emma? Number what? I just didn't hear you. Sure. I like you guys are all stumped on 17 now. You're just excited, I know. Okay, 11. So 9.45 times 10 to the negative fifth. So Emma, if the exponent's negative, do we move it to the left or to the right? Good. So 1, 2, 3, 4, 5. You should have 4 zeros. Then you just didn't move it 5 times. You might have just read the exponent wrong. That happens. On the test, just take your time. Check over it. Mary? Yeah, maybe, but Emma, you should always start, you might be right, Mary, you're probably right. Always start where the decimal point is. I guess, I don't know, I guess I didn't think that would be an issue, but maybe it is. Yeah, you're probably right. Always start where that decimal point is. If there's not one, if it's just a whole number, that's when you start here. Good call, Mary, that's probably the issue. Sean? One through 10. We're going to talk about that. Right. It has to be less than 10. Yes. 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 Does that make sense? Okay. Adam? Okay, that's all right. Anyone else? Question besides 17, because I'm going to get to it. Questions on homework. Thumbs up, thumbs middle, thumbs down on 1 through 16. So not 17, because we're going to finish that today. Okay, Adam, did you remember? Yep. Not necessarily, because it depends on where the decimal point is. So not always, but most of the time, yes. Okay, who can remind us from yesterday without looking, what is the standard form of scientific notation? So something times something to something power. Annalise? No, you got to give me the letters. Yep. Okay, so C times 10 to the nth power. What is the restriction on C? So Sean kind of said this. Justin? Good. What is the restriction on N? What's the restriction on N? Zach? What does N have to be? Good. N always has to be an integer. If you remember what we just wrote down here, scientific notation is extremely easy. If you remember that. Any questions on how to understand this? Okay, Briar, you were absent. You okay with that? Sure. Sean? Because then you get into square roots of things and fractions. For example, I don't want to confuse you, but if you have 10 to the 1/2 power, that means square root of 10. If you have 10 to the 1/3 power, that means cube root of 10. That's algebra 2. If it's 10 to the 2/3 power, it's the cube root of 10 squared. So, okay, let's pause on that so that you guys, your brains don't hurt. Sean, I guess I answered your question. Basically, you will learn this, I believe it's chapter 6 in algebra 2, simplifying rational expressions. There's some crazy problems you'll see that deal with exponents that are not integers. So that's why. Adam. Okay. Okay. we're not going to get into that right now because we don't have a lot of time. You can ask your dad. You said your dad. You can ask him. We need to finish up basic scientific notation before we get into anything more complicated. Annalise, real quick. You don't change it to decimal form, you leave it exact. So if you can't simplify the cube root, you leave it alone. We're going to talk about in a couple chapters how to simplify square roots of things. You'll see what I mean. You don't change them to decimals. You guys haven't, no, you're not going to change them to decimals. For example, real quick, then we got to get moving here. If you have square root of 27, you can change it to square root of 9 and square root of 3, because 9 times 3 is 27. The square root of 9 is 3. So your answer is 3 square root of 3. You don't change them to decimals. Okay, you'll learn that in a couple chapters, so don't worry about that right now. Okay, example 3 in our notes, page 20. You guys are ahead of me. Page 20 in the notes, example 3. Here's what I want to do. I'm going to finish up a couple scientific notation problems that deal with number 17 as well as ordering them. And then you guys are going to do a little bit more practice with that, and then we're going to start the review. Okay, so starting with number 3, it says, put the numbers in order using scientific notation. So before we put these in order, what do you think would be the easiest thing to do here? The shortest way. Alyssa? Okay, you could put them all in standard form. Now, that would require us to change 2 of the numbers, which you could. I might do it a little bit of a different way, but it really doesn't matter. That way works perfectly fine. Briar? Yeah, if you wanted to like take the lazy way out, I'll call it, if you just change this number to scientific notation, you'll save yourself maybe a little bit of time. However, with Alyssa's point, it might be easier to have them all in standard form. That way you can look at the numbers. So raise your hand if you guys want to put them all in scientific notation. Okay, raise your hand if you want to put them all in standard form. Okay, let's do standard form. You can do either way. My point of that is you can do either way. So let's change these 2 numbers to standard form. Okay, so starting with 5.3 times 10 to the 5th. Go ahead and take a couple seconds if you haven't already. Change 5.3 times 10 to the 5th to scientific notation. Standard form. Who can tell us what that is in standard form? Matt? Good job. Okay, let's change 7.5 times 10 to the 4th to standard form. Annalise, what'd you get? Good. So there we go. So now we need to put them in order from least to greatest. So what's the first number? Emma H? Good. So we have 75,000 as the first one. What's the second number? Adam? Good, 520,000. And then the third one is obviously 530,000. What I would then do is put them back as they gave them to you. So I would say 7.5 times 10 to the 4th. This one was given to you in this form, so leave it in standard form. And then the last one, 5.3 times 10 to the 5th. So I would then put them back as they gave them to you in order from least to greatest. So I think these ones are pretty easy. You guys agree? I mean, you can say no, but figured you wouldn't have too much trouble. Okay, let's jump to the closing, but I'm actually going to add some examples to it. So I'm actually considering this part of the notes because this is the tricky part. So skip the oxygen problem. Let's go to the closing. Okay, so this was just like 17 on the homework. So it says find the product, write your answer using scientific notation. So here we go. All we do is take these numbers and multiply them, these numbers and multiply them. So what's 2.5 times 2? Justin? Good. Times 10 to the, when you're multiplying the same base, what do you do with exponents? Alyssa? Add them. 5 plus 3 is 8. That's your answer. Alyssa? I know. They're harder. I'm getting there. A and B are the easy ones. I am adding 2 more examples that are just like that. Annalise? You can put them in standard form, it just takes longer. You can do that. Yeah, if you want to put them in standard form first and then multiply, that's fine. Yeah, always multiply these two, and then always multiply these two. Mm-hmm. Comma H? Okay, that's fine. We're going to get to the harder ones. Okay, letter B. Let's multiply these ones. So we have 1.5 times 4. Just multiply the like term, well, not the like terms, the first part of the scientific notation and then the second part. So what is 1.5 times 4? Alyssa? Good. Times, we have 10 to the negative second times 10 to the negative fourth. When you're multiplying same base, add exponents. Remember, scientific notation is the only time you're allowed to keep them negative. So Adam, what do we get? It's negative 2 plus negative 4. Yeah. What were you thinking? Okay, but listen though, when you multiply same base, add exponents. Over here, we did not do 3 times 5 is 15. We did 3 plus 5. Do you remember that from lesson 4.5? Okay, just making sure. Everyone else okay on A and B? Okay, they're going to get harder. Okay, I want you to write down underneath those letter C first. Now, this is one, oh, actually, let me wait. Go ahead and write it down. Yeah, you can write it wherever you want, on the back, on the same page. It's completely up to you. There is a blank page on the back, as Matt said, so. All right, first thing, take 3 times 4.5. What is 3 times 4.5? Annalise? Good. Times, what is 10 going to be? 10 to the what? Annalise? Good. What's wrong with this one? That was not wrong with the other two. Put your hand up when you realize what's wrong. This is not correct. See, more hands popping up here. What's wrong with this form? Zach, what's wrong? Say that again. You're in scientific notation, you're allowed to have a negative exponent. That's the only time you're allowed. Annalise, what's wrong? Nope. Emma? 13.5 is more than 10. You are not allowed to have scientific notation in this form. So here's what I recommend doing. I recommend that you change this to standard form, and then we convert it the right way. If you notice the shortcut, I'll let you use it. Okay, hold on. So let's write down 13.5. Let's convert it to standard form so you guys can understand what we're actually doing here. So which way do I move the decimal if I'm converting this to standard form? Justin? Good. 1, 2, 3, 4, 5. Add the zeros in. So we have 0.000135. Okay, what do we want to change this to? Mary? So 1, 2, 3, 4. So 1.35 times 10 to the what? Charles? Good. Negative fourth power. That is the correct answer. Annalise? How I got this part? Okay, well, all we had to do was change. 13.5 is not, you're not allowed to keep it like that. So you have to change this to be a number between 1 and 10. So all we did was move the decimal point this way. Well, yeah, not solve. We put it in standard form, and then we found the correct scientific notation. Briar? Well, one bigger. Yes. It's kind of confusing because you always, especially me too, you always think of it as the opposite. But yes, you're making the number smaller and adding 1 to the exponent. the decimal number smaller, I should say. Charles? They use that sometimes, yes. That's what Adam was asking me. I'm not quite sure. That's a good question. Okay, next one. Letter D. Go ahead and write this one down. 4 times 10 to the second, and then 3 times 10 to the third. This is pretty much as difficult as scientific notation gets, which is, I don't think, too bad. Yeah. All right, letter D. Donatus, what's 4 times 3? 12. Alyssa, what's 10 to the second times 10 to the third? Okay, what's wrong with this one? Briar, what's wrong? Good, 12's bigger than 9.99999 repeating. So let's change 12 to be in standard form, 12 times 10 to the fifth. Where's the decimal point on 12? Where's the decimal point, Justin? Good, so the decimal point's here, so we need to move it to the right 5 places. 1, 2, 3, 4, 5. Put the zeros in. Let me rewrite it. What's wrong? What'd I do? I am taking the long way, just to make sure everyone understands it. Okay, now what do we need to do? What are we changing it to? Too easy. Mary? Good, 1.2, so then if you count, 1, 2, 3, 4, 5, 6. Does that work the same way as the rule for the previous one? We moved it over to the left and we added 1 to the exponent. You're more than welcome to use the shortcut, but I like to show you the long way. You guys have learned that by now, so that you understand why something's working. Emma M? No. Why not? Tell me why not. Which way did we move the decimal point? To the right. If you move it to the right, just like we did up here, it's positive. If you move it to the left, it's negative. If it's a big number, the exponent's positive. If it's a really small number, the exponent's negative. Make sense? Okay, Annalise? Okay, can you guys someone explain the shortcut again? Sean? Yep. Good job. So basically move the decimal point to the left once and then add 1 to the exponent. Okay, I want you guys to try 2 more and then we're going to move on to the review. So on the back of that packet you have some room. We're going to call these E and F. Okay, you guys are going to do these ones on your own. Okay, so let's start with 7 times 10 to the 7th times 5 times 10 to the 5th. And the other one, 9.5. Let me move this one over because I'm not going to have room. The other one, 9.5 times 10 to the negative 4th times 2 times 10 to the negative 5th. So just take a minute or two. Go ahead and simplify E and F. We actually could do this the opposite too, where the number could be too small, which means less than 1, but then you'd have to subtract 1 from the exponent. So that would be kind of a different way. Your book does not do it the opposite way though, which is weird. Adam, did you get him? Oops, I wrote that problem wrong, but that's okay. That works. I should have made that negative. Good, good. Let me get mine later, and I'll check it. I just don't have that paper in my hand right now. Good. Because it's stored as a value. Don't worry about that. Yeah, I know. This one needs fixed. -9 plus 1. Oh my gosh. This is not a power, is that what that says? This is an exponent. This one needs fixed. You have to add those. You forgot to add the exponents. Good. All right. Number or letter E. Charles, what did you get? Good job. Okay, letter F. Emma H. Good job. Now, let me just say again what I said before. Your book does not do this, but they could give you a number that's too small, which means it's less than 1. So if it's the opposite, if it's less than 1, what are we going to have to do to the exponent, do you think? If we have to make the number bigger, Charles, what's going to happen to the exponent? Yes, you have to subtract 1 from it. You will not have a problem on a test like that because your book does not show you examples that way. And again, you guys can always put them in standard form to see whether you need to add or subtract 1. Any questions on E or F? The only thing I noticed when I was walking around is please make sure when you're multiplying same base that you add exponents. Annalise? You mean then put it back to scientific notation? Yeah. That's the shortcut way, but you can do it the long way. So if you do this the long way, you have 19 times 10 to the negative 9th. So you would have to write, do you want me to do this or do you understand this? 1, 2, 3, 4, 5, 6, 7, 8, 9. So put all the zeros in. Okay, so then all you're doing now is converting this back to scientific notation, which means you have to figure out how many times you have to move the 0 over to make it 1.9. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's the long way so that you guys understand why we're doing the shortcut we're doing. Okay, here's, any other questions? Okay, not that. Here's your assignment. I can get to it. Okay, in your homework packet, you guys are going to do practice 4.7, 18 to 30. That's not going to take you long. It's just converting things, scientific notation and standard form. The second assignment is in your book, so you can start whichever one you want first. No, it was 1 to 17. Okay. Second assignment's in your book. It is on page 806. It is a 4.5 to 4.7 review. However, some of the exponent problems are not as difficult or challenging as the ones we have done. So it's good practice, but like always, FYI, still study your notes and some of the harder problems that we did in class. Tomorrow, I'd like to do a guided review with you, whether it's on the whiteboards or just together in class somehow, to go over the harder problems with you. So finishing up scientific notation, and then the second part is it's a short review of 4.5 to 4.7. Sean? No, we won't have time because we have to go over all this. I want to do some harder practice problems, so no. Plus, because I'm not going to be here Thursday, I don't want to give you guys homework. I want to make sure you're completely ready for it in class because I'm not a big fan of having subs here. Okay, any other questions? Okay, you guys have about 10 minutes, so if you want to get your book, get your book. If you want to work on the worksheet first, you can work on the worksheet